The classified paper 6 topic experimental technique. We did the first question, and the second question is planning experiment. We have tartazine, which is a yellow food coloring. We have to plan an investigation to find out the yellow sweet contain tartazine, and how would your results will test if the sweet contain tartazine, and you have an access to the lab material and yellow sweet and a sample of tartrazine. You may draw a label diagram as part of your answer. So if it is optional, you may, then you should draw that you to score the marks.
So
first,
we will use the chromatography.
yeah. So first thing, whenever you want to identify the substances like colors, dyes, so it is chromatography. So first, what we have to do, we have a sweet. First thing is extracting the color from it, because in the question they mention
Take a pestle and mortar and grind the sweet with a suitable solvent.
good. Or yeah, first you can first using a mortar and pestle, you first grind and then add a suitable solvent and make a solution. Then what we will do?
Then take a chromatography paper and draw a baseline and a solvent front using a pencil. Fill in a container.
Origin with pencil.
Yes. Then fill in a container with the suitable solvent and put in the chromat. First put the dye, the extract, using a dropper on the baseline, and then place the chromatography paper into the container containing the suitable solvent. Wait for the solvent to rise up to the solvent front.
To the top of the paper. Because solvent front is actually the last place where the solvent is rising. So that place only created when the solvent rise.
Okay.
But your answer is correct. And then how we identify that it is
by using RF value, compare
using
like
the reference RF value of tartrazine.
Yeah, tartrazine. So what actually we'll do, first we'll take mortar and pestle and we will crush the sweet. After crushing it, what we will do, we will transfer that into a container, the sweet, and then we'll add a solvent to make a solution. So we dissolve and make a solution, because solution can be applied on the chromatogram. And then what we do, we'll take a chromatogram. The paper is called, technique is called chromatography, and the paper is chromatogram. And draw the origin with pencil. Then using a dropper, place the color extract from the sweet, and because we want to like a yellow sweet and a sample of a tartrazine is there. So example, this is a yellow sweet and there is a tartrazine, example T is there. Then we use a suitable solvent. Better name the solvent. If they don't mention it is insoluble in water, so you can use water as a solvent.
We can say organic solvent.
Organic solvent, you can also say. But if it is in the question, if they did not specify that it is insoluble in water, then water is the most suitable, because water refers to universal solvent as it can dissolve variety of compound. So if it is not mentioned, then water is the simple answer here. Then allow the solvent to rise on the chromatogram, and then compare the spots, the distance moved by the spot. If they rise, like the spot for a yellow sweet and the spot for the tartrazine rise to a same height, it means that the yellow sweet, like in a yellow sweet, there's a tartrazine. Or you can also measure the RF value for a yellow sweet and RF value for tartrazine and compare them. If they have the same RF value, that also means that it is correct. So by chromatography, crush the sweet with the suitable solvent with pestle and mortar. That's right. Then you can apply heat, like to increase the dissolving, apply the extract on the origin. And how you apply extract?
Actually, we say place it. Dipping will dissolve the extract in the water.
Sorry, repeat what you said.
We say place chromatogram in the suitable solvent, not
Yeah.
dip it, because dipping would dissolve the extract in the solvent.
Or if you mention dip, then you use the term that the origin should be above the solvent level. That is also fine.
Okay.
Like you should specify that. So apply the extract on the origin by pencil, then place chromatogram, use a suitable solvent, then which should be below origin, then measure. Then one more thing you have to mention that allow the solvent to rise. And measure the distance traveled by the solvent and the spot. Then calculate the RF value or compare the RF value. If the yellow suit contain a titration, it will have the same RF value, or the height you can also compare. Is it clear, this experiment planning?
Yes, sir, clear.
In question 3, sodium hydrogen carbonate decompose when heated. The products of a solid sodium carbonate, water and carbon dioxide. The products are solid sodium carbonate, water and carbon dioxide. A student decompose a sample of a sodium hydrogen carbonate. This is sodium hydrogen carbonate. And using the apparatus, as you can see, name the item of apparatus, label A. What is A?
Test tube.
Test tube.
A is
And
test
B is
tube.
inverted measuring cylinder.
Yeah, or if you just mention measuring cylinder, that's also fine. So test tube and a measuring cylinder.
And the container water is in is a trough.
Yeah. But for only they ask for A and B. How we identify the difference between a measuring cylinder and a gas jar? If there was a gas jar, then there will be no labels on that. Because gas jar and measuring cylinder look similar. But what is the difference between both of them? That if there was a gas jar, then there will be no labels on it, on that. Gas jar just to collect a sample, not to measure. What is X? That is the next part. I will answer that as well. Like we heat sodium carbonate, the water is given off, and so as a result, what happened when we are heating sodium carbonate, hydrogen carbonate? So this will turn into sodium carbonate, Na2CO3. It give off water vapors, and these water vapors, as they are moving, they might condense, and as a result, we might get water H2O here. And the carbon dioxide gas will be collected here. The water which is produced might condense, and it will be collected at inside the test tube. So when the sodium hydrogen carbonate was heated, a colorless liquid collected at point marked X suggests the identity of the colorless liquid. What is this colorless liquid?
Water.
Water.
Yeah, water. What about, look, what actually happened? Like this substance was sodium hydrogen carbonate. Like this is NaHCO3. But when we supply heat energy, it start to turn into Na2CO3 plus CO2 plus H2O. These are the three products which are formed. So this whole, like red example, the red dots are representing that sodium hydrogen carbonate turned into sodium carbonate. And other two products are there. One is a water vapors. Another one is carbon dioxide. Water vapor, because they lose energy, so they condense and we might collect them here. But carbon dioxide is a gas at room temperature. So we'll collect the carbon dioxide gas in the measuring cylinder. So this sodium hydrogen carbonate will turn into sodium carbonate. On the diagram, draw one arrow to show where the apparatus should be heated during the experiment, where we should supply the heat energy. Yeah, that's right. Because arrow should be pointed like the heat source. That's right. Better this type of arrow is right instead of from top. Like it's difficult to provide heat from the top, as beaker or the Bunsen burner should be there. So we supply the heat energy from the bottom. State one observation that would indicate that sodium hydrogen carbonate had stopped reacting.
No
What?
bubbles are forming in the measuring cylinder.
Yeah, because how we know that it's all decomposed? Because if sodium hydrogen carbonate decompose, it is giving carbon dioxide. So carbon dioxide gas is collected. Once there will be no more bubbles formed, like all of that is, when there are no more bubbles formed here, bubbles stop forming, we are sure that all the sodium carbonate has decomposed. So state an observation that indicate that, so no more bubbles. Explain why it is important to remove the delivery tube from a water as soon as the heating is stopped. So, for example, when we are supplying the heat energy, the water is like the gas is being pushed. So we are supplying the heat energy from here. It decomposes, it produces a gas. The gas travel. The question is, the
The
moment
pressure can build up.
yeah, the pressure can build up, it might crack the test tube. Like when we should remove the test tube before remove the heating source, because if we remove the heating source, what might happen, inside pressure will be too low, as all the gas is forced to go out. So even the water might return to the test tube, and that may cause a cracking in the test tube. That test tube or a boiling tube might break or crack, as the water will go back into the tube. It's like suddenly a hot thing turn into cold. Like we are supplying heat energy. What actually happened? Like we are supplying heat energy from here, and we are pushing the gas. The gas is formed, and that because of a pressure it is pushed, and we collected here. What the question is, if we remove the heat energy source, then what is the danger here, that what might happen, that water might enter the tube again. Why? Because inside pressure is lower than the pressure here. As a result, what will happen, the tube might crack due to sudden change in temperature. So points you will mention why a delivery tube, so why it is important to remove a delivery tube from water as soon as the heating is stopped. So the test tube might crack because the water will flow back into the test tube, and that cause a sudden change in, like hot to cold, that might crack a substance. Like when a sudden temperature change is there, substance might crack easily. Is it clear, this part?
Yes, sir.
Then the next question related to identification. uh, you will use in paper 6, you will have the identification test and identification chart will be there, the observation and the test. You have to just use the result to indicate. Compared to last year, student used to memorize these ions. For paper 2 and 4, still you have to memorize. But for paper 6, you can use the formula sheet. So solid M and solid N are analyzed. M is iron 3 nitrate. So iron 3 nitrate salt is there. What does it mean? It means it contains iron 3 ion and it contains nitrate ion, which is -1. Test on solid M. test on solid M is there, complete the expected observation. Solid M was dissolved in a water to form solution M. So first it was solid and now we have a solution. And it was divided into two equal portions. So we have two equal portions of solution M which contain iron 3 ion and nitrate ion. To the first portion, we add sodium hydroxide was added gradually until in excess. So if we add sodium hydroxide and we have iron 3 ion, what is the observation?
Red brown precipitate insoluble in excess.
So if you can see the chart here, if we have iron 3 ion in the solution, what it will give? It will give a red brown precipitate which will be insoluble in excess. So here the observation, the first mark you will mention that we will have a red brown PPT. For precipitate in exam, it is acceptable to write PPT, and insoluble in excess, does not dissolve. The next part, the product of A was transferred into a boiling tube and aluminum foil is added. So first we add sodium hydroxide and aluminum foil. What is this test for? Can you identify what is this test for adding sodium hydroxide and aluminum foil?
Nitrate ion.
Nitrate ion. You can see we add sodium hydroxide, then aluminum foil, and then we warm. As a result, what will happen if it's a nitrate ion, it will give off ammonia gas.
Which will turn red damp litmus
blue. So the product was transferred into a boiling tube and aluminum foil is added and the mixture was warmed gently. And any gas produced was tested. So observation, what we will see and the gas is tested. So what we'll test, we test with a damp red litmus, it will turn blue. So there is a damp red litmus, it will turn blue. And identify the gas. Which gas is given off when this is done?
Ammonia.
Ammonia.
So it's ammonia. To the second portion, nitric acid followed by barium nitrate. What is this test for? Nitric acid and barium nitrate.
It is sulfate.
No, this is a barium nitrate is added, yeah, sulfate is there. Nitric acid for barium nitrate, this is a test for sulfate ion. If it was nitric acid and silver nitrate, then halide ion. So, but there is no sulfate present. There is no sulfate present, so there will be no white precipitate because they already mentioned this salt contain iron 3 and nitrate. So there is no sulfate present. So as a result, what we'll observe? So there will be no change. Why there is no change? Because this is a test for what? This is a test for sulfate ion. Because the salt is not a sulfate salt, so that's why it does not give a positive result. No change, no visible change. Test on solid M. So first we did the test on solid M, which was iron 3 nitrate. Then test on solid N is done. A flame test was carried out and the flame is red. What gives an idea about red flame?
Lithium
Lithium.
ions.
So
Lithium ion.
lithium. You can see a red
We
color.
can say red or crimson.
Yeah, crimson, red. So this gives an idea that it is lithium. Then a solid N was dissolved in water to form a solution N. And about 1 cm cube of a nitric acid followed by silver nitrate. So nitric acid followed by silver nitrate is a test for halides like chloride, bromide, and iodide. So chloride, bromide, and iodide. So nitric acid, there is no change. So if there is no change, what we can say? We can say there is no chloride, bromide, or iodide present. So this was a test for the halide ion. This is a test for chloride, bromide, or iodide. But there is no visible change, so it means no halide ion is present.
Test 3 is for sulfite.
Yeah, dilute hydrochloric acid was added, a mixture was formed, and any gas produced acidified purple to. So when you check the test, what is this test for? This is a test for sulfide ion. You can see uh, a small volume of acidified potassium manganate is there,
And produces sulfur dioxide
and it
gas.
gives a sulfur dioxide which turned a purple to colorless. So this give an idea that this is a sulfite ion. So this test indicate that it is a sulfite hydrochloric acid. Is when we add hydrochloric acid and heat, and sulfur dioxide gas is given off. So this is shows confirm the presence of a sulfite ion. Identify the gas produced in test 3. So which gas is produced in test 3?
Sulfur dioxide.
So
Sulfur dioxide.
sulfur dioxide. Identify solid N. So we identified contain lithium and we identify
And
it as
sulfite.
sulfide. So it is lithium sulfide. You can write the name or you can write a formula, but if you write the formula, it should be correct. Like if you write LiSO3, this is wrong because lithium belongs to group 1. Yeah.
Li2SO3.
And sulfide is -2, so cross multiply. So lithium sulfide should be Li2SO3. So I prefer that when you're writing the name, it's right in words, so you will not lose a mark in case if you forgot to write a formula, just write lithium sulfide. SUL, PHIT, SUL, FIT, both are right. In question 5, the diagram shows some coffee beans are there. Caffeine occur naturally in a coffee beans, and caffeine is a white crystalline solid. It is very soluble in hot water but much less soluble in cold water. Plan an investigation to obtain pure crystalline sample of a caffeine from a coffee beans. Assume that all other substances in the coffee beans are very soluble in both hot and cold water. Uh, you have to assume that all the other substances in coffee beans are very soluble. You're provided with coffee beans and some common lab apparatus, and it is of 6 marks.
We will
So, Mr. We
grind
can
pestle and mortar with
Yeah,
water.
1 mark is
And
for crush. 1 mark is for crush the coffee bean. That is one thing. What else we will do by using mortar and pestle? Then
we can add cold water inside. So all the other substances will get dissolved and the crystalline caffeine stays as it is only soluble in hot water.
or we can also do one thing like we put a hot water and we try to dissolve maximum and then we do crystallization.
Yes,
That will be more suitable instead of directly using a cold water, because if we directly use a cold water, maybe some will dissolve, some may not dissolve. So what we can do, we can, as you mentioned in the beginning, we can grind or crush by using mortar and pestle. Then we will add water, make a solution. Then we will heat, uh, make it like, and then we will filter first to remove any. We can do simple distillation, or that's so. Simple distillation, if the question was if we want a liquid from the solution, then simple distillation. But here we want the crystals from the salt crystals or the crystals from a solution. That's why we cannot use, we have to use evaporation or crystallization. Not evaporation, the crystallization. So what we will do, we will add water, then heat, then filtration should also be done because there might be other substances which are insoluble that we remove first. And then we will cool the filtrate and allow the crystals to form, and then we will filter again to obtain the crystals or a caffeine. Is it clear? Anyone having a doubt in this?
yes.
So you can plan this, or should I write the steps? So Yeah, why we first filter? Because to remove any other insoluble substance. That is why first filtration is done. Because first when we crush this, first when we crush this and we make a solution, so there might be some substances which are insoluble. So first filtration is done to remove those insoluble substances. And then we use crystallization to obtain the crystals of caffeine. As I mentioned, all the other substances remain soluble in coffee beans, and in both hot and cold. But caffeine crystals can be obtained by crystallization. So the points you should mention related to this experiment. So we will crush by using mortar and pestle. One point is for crushing. One mark is for using what? Then we will add water and stir. Then we will filter.
Since after we grind it, the solid will be very fine, we can also mention filter through a Buchner's funnel with a vacuum-induced side-arm flask.
Yeah, that's actually what is done. So we will use a filtration, then we will heat the solution, leave the solution for crystals to form or crystals of a caffeine to form, and then filter again. And then we will filter and dry the crystals. We can heat the filtrate. In the beginning, you can take a hot water, you can heat and stir and heat, both can be done at the same time to dissolve the maximum amount. Even you mention stir, that is one point. If you mention heat, that is another point. Why sometimes stirring is enough? Because some of the solute are readily soluble, like instantly dissolved. So that case, stirring is enough. Like example, if you want to add sugar to water or salt to water, stirring is enough. We don't have to provide heat energy. But some of the solutes are not readily soluble. So in that case, we have to. Yeah, activation energy is low, but you can mention that is also a reason. Like some reactions have low activation energy, so by stirring you can provide that energy. But some have high activation energy, so you have to heat and stir both at the same time. The student extract the colored substances from berries. As you can see, some methods are there. Name the apparatus, label A, B, and C. What we call A?
Mortar, tripod
So A
stand, and
mortar
filter
and
funnel.
B tripod stand and C
Filter
filter
funnel.
funnel.
Yeah. Filter funnel. Complete A and B as well. Type right for A and B. Mortar and tripod. The next one, student analyze the colored solution using a chromatography. So as you can see, student analyze this Complete the diagram, show where the spot of a colored solution should be placed. You can use a screen annotation where it should. So it should be on the origin, not below, on the origin. The level of a solvent in the beaker, where there will be a level of a solvent in the beaker in the beginning of experiment. No, in the beginning. Yeah, so it should be below the origin. So level of the solvent should be below the origin. And the spot you can mention. Explain why pencil is used to draw the baseline on the chromatography paper. Why
Because
always?
the ink can dissolve in the
So the
solvent.
ink can only rise, nothing else will rise.
Pencil, the main thing pencil is like, yeah, you can, pencil is not like not soluble. Simple answer is pencil is not soluble or does not dissolve. Where ink is soluble, it will dissolve.
It is macromolecular structure, the graphite, so it does not dissolve.
Yeah. Paper 6, when you answer paper 6, instead of specifically deep in the chemistry, its basic things are there, usually like why something we are using a toxic, if a toxic is there, what things we should use. Instead of mentioning the chemistry, it is true that that is the main reason that it is insoluble because of a giant macromolecular structure. The student made two chromatograms after chromatography. One chromatogram was dipped in hydrochloric acid and one is dipped in sodium hydroxide. The results are shown. Determine the number of colored substances in the
4.
4.
3, I
How?
think.
No, 3. There are 3.
Okay. How you identify there are 3?
They are in
Because
different
Mr.
solvents.
Red and blue and green.
Look, the rule is to identify how many colored substances are there. We don't bother about type of a color. What we bother about is number of the spot. How many number of spots are there?
2.
2.
2.
How many numbers? 2. 2. So it means how many are there? 2. Don't bother about, because why this thing is blue and red here and this is blue and green? Because they might be have different color in different solvents. Like the dye which we are using may have different color. And so important thing. No, why we did not say 4? Look, for example,
If
if
it
we
was
were,
3 or 4, then there would be something left dormant on the baseline, I think.
yeah, there will be something left on the baseline so that it shows insoluble. Look, first when we dipped in hydrochloric acid, how many spots we see? We see 2 spots. So number of the spots shows how many colored substances are there. How many spot? 2 spots. So that's why 2 color. If it's not like 2 color in acid and 2 color in alkali, so it means there will be 4 spots. That is not the way to read a chromatogram. The way to read a chromatogram is to identify how many spots are there in a substance, in a specific solvent. So in acid, it was 2. And in alkaline also, it is 2 spots. So it confirmed that there are only 2 substances present, 2 different substances present. That's why it is giving 2 spots. So even the same question was there without an alkali. If this question was there, directly you will write 2. Why? Because you will see 2 spots. So same thing, don't bother about whether the other chromatography is done. Maybe the third experiment is done in water. The same experiment of chromatography, it is done in water and still we got 2 spots. So will you say 6 spots are like 6 colors are there or 2 colors are there? So in that case also we'll say 2. If, yeah, that is also a good question. For example, if one is having 3, another one is having 2. So the one which is a maximum number, that we will tell. Like the one which is showing 3 color, it means there are 3 spots. The maximum number
Is
will
it
go.
because some solvent can react with a component,
Yeah, that's
make
right.
it invisible,
Make it in. Some
or
react, some
change
does,
color?
or change color. So the if 2 different numbers are there on a chromatogram, the one which is having a maximum, that we will take. Is it clear? Then
Sir, but
yes.
the question didn't specify The paper dipped in dilute hydrochloric acid or sodium hydroxide.
Yeah, so the same paper that determine the number of colored substances in solution obtained from berries. So this is dipped in hydrochloric acid. The solution dipped in hydrochloric acid like chromatogram, and this is a chromatogram of the berries dipped in sodium hydroxide. If you don't bother about two, just if, for example, forget about sodium hydroxide, how many spots do you see? Two. So you'll write two here. Same
Two,
thing.
yes.
Same thing if you don't bother about this one, this result, and check sodium hydroxide. How many spots are there? Two.
Also two.
The table shows the color of some indicator in acid and alkali. Use the data in the table to give the possible identity of one indicator in the berries.
We can check for color because berry has indicators itself.
So no, you can check
So
like example for each of them color in,
anthocyanin
yeah,
is red.
anthocyanin in acid is red. So we acid, did you see any red color? So there is a red color.
Yes.
Like it means this give because
Anthocyanin is blue in alkali, so we see a blue color
we see a blue
in
color as well.
sodium hydroxide.
So it means that indicator is anthocyanin. Why not bromothiamol blue? If bromothiamol blue, what should be the color? It should be yellow, but there is no yellow color present. So there is no yellow color present, so it cannot be bromothiamol blue. Congo red. Congo red, it should be blue. So there is a blue color, so it might be Congo red, but in alkali it should be red, but there is no red color, so that's why it is not Congo red. Methyl purple. So there should be a purple color, but there's no purple color present in acid. So only color which is match, that is in acid it should be red. So there's a red color in acid, and in alkaline there should be a blue color. So anthocyanin is the right answer. Is it clear?
Yes, sir, clear.
Yeah, first indicator, there is a blue color because the idea is that there might be there might be another indicator present. We want to find one of the indicator present. There might be another indicator present which is having a blue and green color, blue color in acid and green color in alkaline. But we want to find one of the indicator which is present in these berries. So one of the indicator which is present in the berry, that is anthocyanin. Yeah, berries have indicator, even different like reddish also, these they all have indicators. So this was question number 6.